Good evening, everybody. It's nice to meet you all here. My name is Iryna Gurevych, and I'm from Germany, from the University of Darmstadt. I talk about fact-checking today. This is a topic that any of you can relate to. I assume that many of you are researchers or students, so you need to read scientific literature and check the claims. But even if you are not a researcher, you for sure read news. And we all know that nowadays we should not just believe the news. So in our work, we try to design some automatic support for checking the facts. And we try to design systems which are not just effective in technical terms, but which are also practical, that is useful. And also there's like a difficult truth here. The truth is that the truth does not always exist. So this is a paradox. So it's not always possible to check the facts accurately and arrive at a clear verdict. So what I have here today is an example from a very recent article online from United Nations. So that's quite like a good source. And what you see, obviously, you can recognize is a picture taken in Israel after the terrorist attack on the 7th of October. And now if we read the article that comes together with this image, so we read the following: schools and hospitals filled with civilians, primarily women and children, cannot substitute a legitimate military target for either state or non-state armed groups, the experts said. And then they say the grievous destruction of El Ahli Hospital underscores the humanitarian consequences of non-compliance with international humanitarian law, they added. So I think I don't have really to explain that this statement has quite a flavor. So as far as I know, there was no Israeli targeting of schools and hospitals, and the investigation by Western intelligence of this hospital bombing pointed out that it was a failed launch of the Islamic Jihad from within Gaza, and it was leveraged by the propaganda to blame the other party. And even the Wikipedia acknowledges that in a page about bombing. So what is the truth here? It's hard to know what is right and what is wrong. And we live in a very complex world where we have to deal with such claims every time to make up our opinion. So before the crisis in the Middle East and before the war in Ukraine, a lot of research in fact-checking in NLP has been done in the COVID-19 domain because, as you know, the pandemic was a big event that generated a lot of propaganda, fake news, and so on. And there has been this claim, hydroxychloroquine cures COVID-19, and as a result of this claim that was circulated on the social media in the US, people have died, basically, because they believed the claim. So this is really dangerous. So it can heat up social pressure and produce unrest in the society, but it can literally also kill people. So at that time, a couple of years ago, a lot of research funding has gone into the topic of fact-checking in NLP, and NLP is supposed to debunk the claims. So what does it mean? We look for the evidence to confirm the claim or counter-evidence to reject the claim. And how is this done? So typically we have a claim and we have evidence consisting of multiple text snippets, and we try to make an inference and infer the claim from the evidence, then it's true. And if we cannot infer it, so the logical relation is corrupted, so we reject. one problem people observed with this in COVID-19 domain, because as you remember, especially in the beginning, the information was spread extremely quickly. And there was not much scientific knowledge about this domain, is that there is hardly any counter-evidence to the claim that were circulated. So, for example, there is no direct counter-evidence that hydroxychloroquine does not cure COVID-19. You just don't know when the claim appears. And at that time, some research works have started to realize that the approaches that NLP has developed in fact-checking over the last 10 years somehow cannot really help humans. And some colleagues have made such claims that fact-checking cannot really replicate humans in a foreseeable future. It may assist the human. And others have said fact-checking suffers from credibility issues and lack of human intuition, or verification and evidence selection requires human-level intelligence and deep understanding of the real world that the machine does not have. So the question is, in which ways can NLP still help people to fact-check the information? And this is what we deal with in our research in my lab in Darmstadt. We zoom in on the gap between human and NLP fact-checking of information. So we look at the question, so how do humans perform this task? And we try to think, departing from this human way of fact-checking information, so how can we support humans in this task in various steps? So we empirically compare NLP and human fact-checking. We find key limitations of the current technology in order to effectively help humans to reject false information. And also one particular unique selling point of the work in the lab is that we focus on harmful and novel misinformation. So this is a particularly difficult type of misinformation, as you will see. And why do we do so? After looking at the claims that are discussed in major fact-checking websites online, we find that the amount of false information in the recent years is rapidly growing. So while in the previous years we had similar amounts of false and right claims, nowadays the amount of false claims, that's the blue curve, is overwhelming. So we need specifically technology to address these realistic false claims, which may differ in their composition from true claims. So first we need to define what is real-world misinformation. We define it as non-true harmful claims that professional fact-checkers deem important to verify. So in theory you can verify every second statement, right? But the human capacity is limited, the task is very expensive, so we need to prioritize such non-true harmful claims. And how do fact-checkers prioritize this? They prioritize this by volume. How much is the claim circulated in social media? So what is the potential for harm for many people? And also the relevance to the people. Now, let's look at a couple of examples of claims that are fact-checked. So one is Coldplay is French. The other is 500,000 sharks could be killed to make the COVID vaccine. And the last one, Beat It, is not a song by Michael Jackson. So it's not a very large audience, so just a question to the audience, what is real-world misinformation here? So any hypothesis? Sharks. So why do you think it's sharks?
It's relevant and potentially it's a great group of people that care about.
Pardon?
I think it is data misinformation, or maybe everything, but data, for example, can be a song for our player, not only Michael Jackson.
Yeah, I really don't know if it's true or false, but just to tell you the point why I'm showing this is that these two claims are taken from the most popular NLP dataset for fact-checking called Fever. So for 10 years, the whole community works on Fever. And I think it's very easy to see that the claim about the sharks is somehow different. Now comes the next question. So I hope for the support from the left side of the room now. So why is this claim about the sharks is challenging? In one of the talks, I even had a real debate with a biologist present.
I guess it has real-world consequences.
Yes, so there's much at stake. Yeah, you are from the right side, but nevertheless, you're welcome.
Maybe you formulate it, like
Yeah.
many sharks could be killed for that.
Okay, so it's hard to imagine we can just go to Wikipedia and look it up. Okay? And that's a major point you realize, and we realized in this work. So somehow it seems quite obvious, but yeah, as I told you, for 10 years, nobody realized that. So the Fever claims are pretty simple. You know, these are short sentences. And how are they created? They're created by crowdsourcing. So people got some sentences from Wikipedia articles. They rephrase the sentence to make a claim out of it. What does it mean? So basically, we can go back to Wikipedia and verify the sentence. It's like a sentence verification task. And for the real life claim, 500,000 sharks, so it becomes really difficult. You know, you need to first figure out so about vaccines and COVID-19. So what is the composition? Do they use sharks at all? And how many sharks do they use? You need to find different quantitative evidence and aggregate it, okay? So you need really to reason to verify this claim. You cannot just go to somewhere and look it up, you know, because most obviously it will not say directly that to make this vaccine, you need to kill that quantity of sharks. Okay, so that shows you the difference between what NLP has been doing before and what real life problem is. So of course we create tasks and they are abstractions over reality. So now let's look what the architecture of NLP looks like typically in fact-checking. So we have some trusted knowledge base. It can be a big collection of documents. We have a claim like Sydney is the capital of Australia. We go to this knowledge base and we use some kind of information retrieval like a search engine to retrieve some facts and evidence. Here it would be Canberra is the capital of Australia, and then we can do this veracity prediction, so we can make a verdict by applying some text classification. We present two statements together and we have a machine learning classifier to say it's support or reject, basically, and then we have this verdict, which is false. Now, with the claim of hydroxychloroquine cures COVID-19, where do you go? So there is no article about this curing or not curing COVID-19, so basically no counter evidence. And the mainstream NLP approach cannot resolve this task because it cannot find any evidence for this. No evidence pro and no evidence contra, so it would say it does not know if it's true or false. So now let's look at how humans reason about information, and this is useful for everybody here, right? Because as I said, we all read news and we want to understand and make up our mind what the news is saying. So usually if something happens, think about this attack on the hospital in Gaza. So when the claim is published and the propaganda is picking it up, there is no counter evidence. The investigations may take forever, right? So we cannot just go and read somewhere, and even after the investigation by the American intelligence, you know, it's also a question, do you believe it or not? You know, we don't know. So what fact checkers do, they usually check where the claim comes from. So what is the context of this claim? Who is making this claim? Who is the claimant? And then they try to understand the political agenda. So here it was, I believe, some kind of anti-vaccination party. And they have a political agenda they want to promote, right? So, and the fact checkers can bring together a lot of contextual knowledge in order to reconstruct the story behind the claim. And they can also ask other people, like experts. They can bring additional knowledge in this reasoning process. And of course, they also check scientific literature. And this claim was provided even with a scientific article on the social media. But now when they check the article, what do they find? The article is from 2005. So obviously, COVID-19 did not exist in 2005, so it's actually about a different virus, and also it's about in vitro experiments on cells that do not apply to human beings. Okay, and therefore, so there is a false link. The claim is supported by a scientific article. It looks very credible. Who would not believe a scientific article? But only very few people would really read the article to check the claim, right? But the fact checkers do this, and this is why this is so expensive, you know, because reading long documents requires a lot of time and effort. So why am I telling you this? So humans use the source of the claim in their fact checking, and this is required by their guidelines. Fact checkers do not just check the claim somehow. They have a certain protocol to follow. And they need to follow the sources provided by the claimant and include both the sources and the claimant properties in the fact verification. And the question, how do you know this, is at the heart of fact checking. Okay, and this is basically when you read the news, you should be asking this question. So in order to find and use evidence based on the source that is provided, we need contextual knowledge. So when the study says we report that chloroquine has strong antiviral effects on SARS-CoV infection of primate cells, we need to add additional knowledge, like in vitro studies are not predictive of the effects in humans, chloroquine is not hydroxychloroquine, it's a different substance, and SARS-CoV is not the virus causing COVID-19. So this knowledge is added. And then we can say that the evidence provided together with this claim is actually technically irrelevant to the claim, and therefore the claim is unsupported. But what would the current NLP approaches do? So the current NLP approaches typically measure the similarity between the claim and the evidence to recognize the evidence as relevant. It's based on semantic textual similarity, and then they would conclude that this evidence is relevant, but it's obviously irrelevant when the contextual knowledge is applied. And adding the source, this is an important kind of consequence of this study, enables multiple ways to attack claims. So while the current NLP attacks claims with counter evidence, you remember this fever data set I've shown you. This is the mainstream approach. We need to reason about the source, and if we include the source in the fact-checking process, there are multiple ways how we can attack the reasoning. First, we can identify fallacies on reasoning from the evidence, that is the source, to the claim. Second, we can attack the credibility of the source. You know, this, for example, specific party may not be credible. So who is saying something is obviously a very important indicator. And also the factuality of the source. So how certain is this information? What kind of proofs do you have that you can rely on this information? And here comes the first piece of work that is built on top of this to make the world and the fact-checking better in the first step. So we do this analysis to identify human fact-checking strategies behind debunking the information to inform the design of NLP, that is AI approaches. In this study, we manually analyze 100 claims taken from mainstream fact-checking websites. And we look if the claims are applicable for natural language processing at all, and we find that they are not always applicable. Sometimes they contain images, which NLP alone cannot resolve, and imposter content, which NLP also cannot address. And it turns out from 100 instances we can address, that's the upper bound, 75 by NLP at all. And then we read the fact-checking articles and we extract the strategies that the fact-checkers apply, like global counter-evidence, no evidence assertion, non-credible sources, local counter-evidence. I don't go into details, but the main point here is based on the current NLP approach that reasons with counter-evidence, we can solve only 20 of these cases. So this is the global counter-evidence strategy. So imagine from 100 real-life claims, we can do only 20. That's it, not more. And the rest is not applicable by design because it depends on knowing the claim source, as I have already presented to you. So that raises the question in that work, how realistic are NLP fact-checking data sets? So another question we look into is the content of the data sets. So realistic fact-checking data sets for novel misinformation need unleaked and sufficient evidence, and they need, as I said, important misinformation claims, right? So what do we find? We find, for example, this claim, you get free coffee for smashing shatterproof Starbucks windows. So in the current world we live in, we can, of course, debate if this is really an interesting claim that relates to many people. But apart from that, and much more worse, we need realistic evidence. It should be unleaked. That is, when we try to evaluate the claim, so there is no previous evidence that we can use in a realistic situation when the claim is just published. But how do we construct these data sets? We go to the internet, we collect claims, and we also crawl fact-checking articles, and we put this all in our training data, and then we say, okay, fact-checking has 80% performance, right? But it's very easy because it contains already checked claims together with fact-checking articles in the data set. So this methodological design is a flaw, basically, but this is what has been frequently done. And also the evidence must be sufficient in order to arrive at a verdict, but it turns out that many pieces of evidence, like an explosion damaged a sidewalk bench and shattered window at Starbucks, are insufficient. So in many cases, the documents that we have do not allow to make a verdict because the evidence is insufficient. So these data sets are not representative of the real-life problem. And at the time, it's 22, the article, we realized, we analyzed the fact-checking data set existing at the time, and we found that they either present no real-world misinformation, it's like the fever data set with claims constructed artificially, or the evidence that they use is insufficient or leaked, which makes the results that we achieve on the benchmark not really valid in real-life settings. And I have to admit, my group has also contributed to these data sets, so we were not kind of born with this wisdom. We just realized this at some point in our work, but we have also contributed 2 of these data sets, and I think it's good work. You know, I'm not really criticizing it. I think it has helped a lot to establish this area of research, but research is moving, and we realize that some decisions and choices we have made may not be the best ones, and we need to change something. So future directions, we believe we should look very closely what humans do in the fact-checking for multiple reasons. First, to design useful abstractions from real-life problems that we call tasks. But second, also to find sub-steps of this process, which is extremely difficult to support humans in specific areas. And second, we should include the sources, and I've talked a lot about it, why it is needed. We need to use realistic evidence, and also we need to invest in reasoning, because think of the example with the sharks, and I have another one. Kathy Manning gave nearly 1 million to liberals. So it's impossible just to fact check this by comparing sentences as such. Here you need more complex operations. You need to find all the donations that she has given from multiple documents, and you need to aggregate this information, and only then you can make a statement about the claim. So much more complex technology is needed to support the real life task. Now we found that fact-checking is harmful, and real-world misinformation is very hard. And we have also analyzed a specific subset of this misinformation, specifically real novel claims. You can, and it's your good right, ask me a question. So what are you doing about it now? And this is what I'm going to tell you next. So what we are doing now is looking at simpler and less harmful claims where we can expect to find evidence. So though we cannot rely on evidence in many situations, but some evidence is available, and we think that we can provide a complementary tool to a fact checker in the cases where evidence is available to reason about real claims. So here the focus is really on real life claims. So this work is joint work with some other colleagues from Cambridge and other places, and we also started this work together with Google Research, but the project has turned out to be so hard. We worked on this for 2 years that Google Research at some time gave us the money for the project, but dropped out themselves because they did not have that much patience to work on it. It has turned out to be a very difficult project, and you will see why. So here we want to create a realistic data set with real-life claims and evidence. And this is different from the prior mainstream data set Fever, and the authors of this data set are co-authors in this work, by the way. And we want to have realistic evidence, and we use Wikipedia here as our documents. And also the claims, different to Fever, are constructed independent of the evidence. So it's not possible just to do this simple sentence matching by design. And we annotate the relevance of the evidence to the claim. So how do we come up with the claims? Google has shared a data set with us called Bulku. And these are like something in the order of maybe 15,000 real-life queries by users. They are not real claims. They are more representative of information needs of users that they put into a real-world search engine. It could be, for example, a question: is it illegal in Illinois to record a conversation? And then we have crowdsourcing, and the crowdsourcing basically restates this Google query as a claim. So the claim that results from it is illegal in Illinois to record a conversation. And the point here is that the claim is created independent of the evidence documents, making the task much harder. Now we retrieve Wikipedia articles. They are long documents, as you know, and we split them into sections, and then we split them into paragraphs, and then we annotate the relevance of each passage for each claim. So now you understand why it was necessary to involve Google in this project. So what do you think? So why do we need Google?
Because the facts are changing in the world.
Yeah, so they gave us the data set, but it's really available. So it's a research data set published, but for this whole story annotation. So, pardon? Computation?
Google has that power.
Yeah, so here it's all done by people, human computation. But you are sort of driving at the, you know, reason behind that.
Can the go track when the Wikipedia site is posted?
No. So this process is extremely expensive. We need money from Google. I think this annotation have cost us like $10,000, not 100. No, 100. 100.
If one person is posting on Wikipedia some content, he or she has searched in Google some data information, and he or she has sources about this data also. It is not only Wikipedia behind this.
Yeah, obviously it's not only Wikipedia, you're right, but you know, in research in NLP, we also have this issue with like copyright, you know, and because of copyright, we cannot use any source because we want to publish the data set and make it reproducible.
For the region and
Hmm?
if the data is for a region, for example, where the poster is from,
Yes.
we can sum up this data. It is not personal.
Yeah, so the queries we can publish, and because we restated them, and the data set is freely available anymore. But anyhow, so I just wanted to let you know, so constructing such a data set is incredibly expensive because we have, like, as I said, about 15,000 queries, and we have long documents, and then you need to annotate all relevant passages, and then we annotate sentences in those relevant passages. So it looks like this. We have the passage annotation, and then we have sentence level annotation. And we have a 2-round annotation process for each instance of passage and sentence. We have 2 annotators. And if the instances have only neutral annotations, that is not support and not reject. They stay as is, but if one is non-neutral, we add 3 further annotators. So some instances have 2 and some instances have 5 human annotations. And then in NLP, we usually look in human agreement on the task, because if the agreement is very low, we say that we cannot really consistently use this data for evaluation as ground truth. And what a wonder, the task is quite difficult. So we have the agreement of 0.5, which is like maybe average, bit weak, and less on the sentence level. This is not what we have hoped for, and in the example you can see we have like 3 neutral and 2 refuting annotations. So humans disagree on this task. It's not very obvious. So we spend more effort on this, and then we add tags uncertain to all these annotations. So the annotation process took, as I said, very long time, maybe 18 months, with all the stages. And we add relevance annotations to the neutral instances because in these cases we think that no clear decision boundary exists. Why do we do this? We do this because we build 2 subsets of the data. So this MBFCC, so this is a subset of the data which is certain. So here we have high consistency of agreement. And the MBFCU, so this is an uncertain one where humans disagree. And in this data set, we have 10,000 claims, 5,000 pages, and 51 claim passage pairs. And we find that many uncertain instances contain neutral annotations. So it means like the sentence or the passage talks about your claim, but not such that you could arrive at a decision if it supports or rejects. So it's related and relevant, but you cannot make a clear verdict. And also we find that contradictory annotations for the same claim are much more frequent on the uncertain subset. So here it's interesting because it's not only neutral and reject, but you have like some people say it supports and some people say it rejects, though the pieces of information are exactly the same. And that shows that people just reason differently about the information that they see, and therefore we have these contradictions. Then we look into many, obviously, research questions. It's a very long journal article. One of them is, can we link disagreements for claim passage pairs to linguistic inference phenomena? So there are not so many linguists in this audience, I assume. But I try to explain this. We have like 6 different categories: implicature, presupposition, co-reference, vagueness, probabilistic enrichment, and under-specification. So you don't need to understand this all. I just talk maybe about under-specification. And here we have a case if the truth variable depends on specific conditions which are not stated. So the claim is, for example, you cannot have a skunk as a pet. But then the evidence says it is currently legal to keep skunks as pets in Britain without a license. Okay, so there is an under-specification in the claim. The claim is very general, but then you have this evidence which is much more specific. And actually, this is a frequent problem in student theses or papers. They make very broad claims, but then if you look at the evidence maybe supports 10% of the claim, right? So that's very much applicable to the research domain as well. And then we find that these linguistic phenomena are significantly correlated with the disagreement. So whenever we have such linguistic phenomena, for example, under specification, that's the reason why one human says, this is an example where I accept, and the other says in the same evidence I reject, okay? Because it depends how they can also argue and reason, and this is something that not every human is at the same level. And then we also check for some other linguistic features, more shallow features, and we find that negation is also a frequent reason for disagreement, so it's significantly correlated with the disagreement. So humans have trouble in resolving the negation, and it's hard to judge these instances. Now, the question is how models can learn from these annotations. And typically, the evaluation is done such that the models must select the correct evidence and the veracity. And we use different measures like sentence level F-score for evidence and 5 different metrics for veracity prediction, where we compare the distribution of human judgments and the machine judgments. And then these metrics are summarized in a joint evaluation. And here I just show the key result to you. So the best performance that we get with state-of-the-art NLP on this task is around 0.5, 0.6. This summarized measure, the scale is from 0 to 1. And what can we see here is that if we use oracle evidence, that is the ground truth evidence, and only do the veracity task, the results are much higher. So the evidence selection needs improvement. Another key observation in this result table is that if we split the results on veracity prediction by our certain and uncertain data sets, we see that on the certain data set, the results are pretty high, but on the uncertain data set, there's a big room for improvement. So we need better ways how we can cope with these linguistic phenomena, which I have explained are mainly responsible for human disagreement. Now, lessons learned. We created a more realistic fact-checking data set with very big effort, so I would never do such a project again in my life. We identified that the disagreement is inherent to the ambiguity between claims and the evidence, so we need to look more into annotated disagreement on realistic data. And also, for the first time, we modeled the fact-checking by predicting the label distribution. So we do not make just make one verdict at the end, but we predict a distribution of different labels by machine learning methods, and we compare this with the human distribution. And yeah, so that actually something that captures the uncertainty inherent to fact-checking, whereas the previous research only used the binary classification task, or maybe support, reject, and neutral, 3 different labels, which is not enough to capture the complexity of the task. So for anybody who's interested, the data and everything is available. And now, just to conclude my talk, I would like to announce 2 projects, very short, that we work on right now. So the previous work is already published, and this work is ongoing. So what do we do here? So the title is Exposing the Flawed Reasoning When Misinformation Misrepresents Scientific Documents. So to understand what I'm talking about, I go back to this hydroxychloroquine claim, because this claim, as you remember, is published together with a scientific article, okay? And then we have a fact-checking article that debunks the claim and concludes that the claim is wrong. So in order to kind of build a system that can act as a fact-checker, we want to have a data set where we can train basically a fallacy classifier. So in order to arrive at such a data set, we take this claim, hydroxychloroquine is a cure for COVID-19, and we take the premise, which should be chloroquine, reduced infection of the coronavirus, and we identify the problems that appear when we try to reason from the premise to the claim. And one of them is, for example, the study use cell cultures for their experiments. So this is a problem that the fact checker has identified. So we extract this from the fact-checking articles, and we then reformulate it, like the fallacy is that the result can be transferred to humans because the human body consists of cell structure, and this fallacy is the fallacy of composition. So there's a certain kind of set of fallacies that humans use, and we reconstruct these fallacies behind the claim and the evidence. And we take the fact-checking articles from a website. They are created by experts, and basically this way we create a training data for the fallacy classifier that is able to expose such fallacious reasoning given a specific claim and the scientific article that is supposed to support it but actually does not, since there is a fallacy in between. So second project that has just recently started in collaboration with an LS student that has joined my lab and a colleague in multimodal reasoning at the University of Leuven is about multimodal fact-checking. So we live in a world of images. I don't have to tell you, think about the wars and everything. It's terrible. So we are exposed to this really very horrible pictures. And we know, of course, that visual misinformation is flooding the internet. There are various kind of problems with images. Sometimes they are out of context images. The photo claims to be in Antarctica, but in reality it is taken in Greenland, right? But the photo may be demonstrated like for climate change or whatever context. Then we have manipulated images. That's the second in the row, where the image of Mark Zuckerberg at the Congress is manipulated. And the last one is a totally fake image, which is AI generated. And now it's as easy as never before to produce such images in high quality. So same story. Before we start developing some AI to fact-check multimodal information and to fact-check images, we look at what human fact-checkers do with images. And this is a recipe for you when you read the news next time and look at the image. So first question, is it the original image? Second question, who created the image? When does it take place? Where does it take place? So many images that are presented as images from Gaza are actually from Afghanistan, so they have nothing to do with Gaza. but we do not realize that. And also, what is the motivation behind the image? What kind of emotion they want to induce in humans who consume the image? And again, I'm not the first one to work on multimodal fact-checking, but when we compare the human approach and the machine approach, the humans collect cues by processing raw evidence, and they answer sub-questions related to these 5 pillars, and they put the media in its original context. It's a comprehensive investigation work. Again, we reconstruct the story behind the image to reason if it's the correct one or if it's a faked one. So what do we do in multimodal fact-checking? We collect raw evidence, we collect other images, and then we answer just one question: is the claim true or not? So this is a binary classification task, and we compare the media with their claimed context. So for example, there comes an article with text, we compare with this context, but the context is also not very reliable, so it's flawed. So in this project, we hope to develop approaches to multimodal fact-checking that will be more practical and more useful for us, and will support answering these 5 questions about provenance, source, location, date, and motivation of the image with the help of AI tools. Now, take-home messages. So I talked a lot about misinformation detection, and I hope you realized it's a very hard problem that is not accessible to current technology because of its complexity. State of the art is that many existing approaches, I think I claim 95% that is done on fact-checking is based on unrealistic assumptions. And in our work, we have found that it's extremely important to model the inherent uncertainty of fact-checking in automatic approaches, because it's not a binary classification task, and always remember the truth may not exist, right? So we want to help humans be better with this. Thank you very much for your attention.